discuss about hermite polynomials. Hermite polynomials are classical, orthogonal, polynomial sequences. Hermite polynomials have many applications. They are extensively used in numerical analysis, in calculating Gaussian quadratures. They are also used in physics for calculating the eigenstate of quantum harmonic oscillator. There are two ways of standardizing hermite polynomials: probabilist hermite polynomial This probabilist hermite polynomial is represented by hen of x, where hen of x is equal to minus 1 whole power n into e power x square by 2 into nth derivative of e power minus x square by 2. The second method is physicist hermite polynomial. This is represented by hn of x, where hn of x equal to minus 1 whole power n into e power x square into nth derivative of e power minus x square. Now we are going to discuss the relation between probabilist hermite polynomial and physicist hermite polynomial. Now the relation between probabilist hermite polynomial and physicist hermite polynomial are hn of x equal to 2 power n by 2 into hen of root 2x, and hen of x equal to 2 power minus n by 2 into hen of x by root 2. This is the relation between probabilist hermite polynomial and the physicist hermite polynomial. Now Hermite's differential equation. Probabilist hermite polynomial and physicist hermite polynomial are the solutions of Hermite's differential equation. Hermite's differential equation is e power minus x square by 2 into u prime whole prime plus lambda into e power minus x square by 2 into u, which is equal to 0. Pursue relation between probabilist hermite polynomial and physicist hermite polynomials. hen plus 1 x of x equal to x into hen of x minus hen of x whole prime. This is for probabilist hermite polynomial. Hn plus 1 of x equal to 2x hn of x minus hn prime of x. This is for physicist hermite polynomial. Now we will discuss the value of the hermite polynomials at 0. Hn of 0 equal to 0 if n is odd, and minus 1 whole power n by 2 into 2 power n by 2 into n minus 1 factorial if n is even. Now the value of probabilist hermite polynomial are hen of 0 equal to 0 if n is odd, and minus 1 whole power n by 2 into n minus 1 factorial if n is even. Discuss about laguerre polynomials and their relation with hermite polynomials. Laguerre polynomials are solutions of the differential equation x double prime plus xy double prime plus 1 minus xy prime plus ny equal to 0, where n is a positive integer. As you can see, this is a second order differential equation. The applications of laguerre polynomials are: they are used in computing complex integrals of the form integral 0 to infinity f of x into e power minus x dx. Laguerre polynomials can be represented by where ln of x equal to e power x by n factorial into nth derivative of e power minus x into x power n, which is equal to 1 by n factorial into d by dx of minus 1 whole power n into x power n. Laguerre polynomials can also be written recursively as L minus n of x equal to e power x into Ln minus 1 of minus x. As you can see, this is a recurrence relation between the Laguerre polynomials. Now we are going to discuss the relation between Laguerre polynomials and the hermite polynomials. h2n of x equal to minus 1 whole power n into 2 power 2n into n factorial into ln power minus half into x square of x square. h2n plus 1 of x equal to minus 1 power n into 2 power 2n plus 1 into n factorial into x into ln whole power half into half of x square. This is for even hermite polynomials and this is for odd hermite polynomials. So this is everything about Laguerre polynomials. Now I am going to explain about moment of inertia matrix. Angular momentum of any rigid body is equal to I into omega, where I is the moment of inertia matrix. It can be represented as follows: Ixx, Ixy, Ixz, Iyx, Iyy, Iyz, Izx, Izy, Izz. Now we are going to derive this rotation matrix using angular momentum principles. Angular momentum of any rigid body can be written as the summation of angular momenta of all its particles. This is equal to here Vi bar is equal to m into Vi bar, and Vi bar can be written as omega I bar cross Ri bar. As omega I is same for every particle, finally we get this equation. Where Ri bar is the position vector of the particle and omega bar is the angular velocity of the rigid body. This is a vector triple product, as you know. A bar cross B bar cross C bar is equal to A dot C into B bar minus A dot B into C bar. By using this and expanding this triple product, we get sigma I equal to 1 to n m into Ri square into omega bar minus Ri dot omega into Ri bar. Here Ri square is equal to xi square plus yi square plus zi square, and Ri dot omega equal to xi omega x plus yi omega y plus zi omega z. Substituting this in this equation, we get minus xi omega x plus yi omega y plus zi omega z of xi cap yj cap plus zk cap. Now by expanding this equation and rewriting, we get L bar is equal to sigma I equal to 1 to n m into I cap of omega x of y square plus z square minus omega y of omega y of xi yi minus omega z of xi zi plus j cap of omega y of x square plus z square minus omega x omega x of xi yi minus omega z of yi zi plus k cap of omega z of x square plus y square minus omega x of xi zi minus omega y of yi zi. This is the angular momentum equation. Now we have to convert this into the moment of inertia matrix form. Angular momentum equation of the complete rigid body. Now by assuming sigma I equal to 1 to n m into yi square plus zi square is equal to ixx, and sigma I equal to 1 to n m into xi yi is equal to ixy, and sigma I equal to 1 to n m into xi zi equal to ixz. Similarly, in the same way, substituting the other terms with iyy, izz, iyx and so on, we get the final equation as L bar equal to ixx omega x plus ixy omega y plus ixz omega z I cap plus iyx omega x plus iyy omega y plus iyz omega z j cap plus izx omega x plus izy omega y plus izz omega z k cap. This final equation can also be rewritten as axx, axy, axz, iyx, iyy, iyz, izx, izy, izc into omega x, omega y, omega z. Therefore, this is the final rotation matrix for the complete rigid body. Discuss about rocket propulsion. Consider a rocket moving away from the surface of the earth and let q be its position vector and q naught be its velocity. Now we are going to derive equation of motion for this rocket using two methods. First method, Lagrangian method. The kinetic energy of the rocket is half m q dot square and potential energy is mgq. The Lagrangian of this system is now we will apply the Lagrangian equation on this system. Lagrangian equation is d by dt of dou L by dou Q dot equal to dou L by dou Q. In this equation, dou L by dou Q is equal to minus mgq and dou L by dou Q dot equal to mq dash. On substituting these values in this equation, d by dt of mq dash equal to minus mgq. On expanding this, mq double dash plus dm by dt of q dash equal to minus mgq. By rewriting the terms, mq double dash plus dm by dt into q dash plus mgq equal to 0. This is the equation of motion for the rocket propulsion using Lagrangian method. To derive the same equation of motion using Hamiltonian method, the potential energy of the rocket is mgq and kinetic energy is half m q dot square. The Hamiltonian of this system is kinetic energy plus potential energy, which is equal to half m q dot square plus mgq. Now we are going to apply the Hamiltonian equation on this system. Hamiltonian equation is dp by dt is equal to minus dou h by dou r bar, where p is equal to dou L by dou Q dot. Now, by applying this equation, first finding p for the system, p is equal to dou L by dou Q dot, which is equal to dou by dou Q dot of half m q dot square minus mgq, which is equal to mq dot, and dou h by dou q equal to mgq. Because potential energy depends only on the position vector but not on the velocity vector. Now substituting these two in the above equation, which is equal to q double dash plus dm by dt into q dot is equal to minus mgq, which is equal to m into q double dot plus dm by dt into q dot plus mgq equal to 0. This is the final equation of motion for the rocket propulsion. As you can see, we have arrived at the same equation of motion using both the methods, that is Hamiltonian method and the Lagrangian method.